All right, in this video we're going to talk about the idea of directional derivative. So directional derivative just means to take the derivative in a particular direction. And we're going to use gradient to do this. And so the formula for how to do this is we just take the dot product of the gradient with the unit vector in the direction that we want to take the derivative. And that's it. That's the directional derivative. So let's look at this example. Find the directional derivative of this function at the point -1, 2 in the direction of 3, 4. Okay? So let's first find the unit vector corresponding to this direction. Okay, so the unit vector here is going to be, well, I'm going to take this vector and divide by its magnitude. So I'm going to take the vector 3, 4 and divide by the magnitude of 3, 4. Well, what's the magnitude? Well, it's 3 squared plus 4 squared square root, right? Well, that just happens to be equal to 5. So it's just the vector 3/5, 4/5. Okay, so we found the unit vector in this direction. And so what we're going to do is we're going to take the gradient of this function at this point and dot it with this vector. Okay, so that's what the directional derivative is. It's going to be the gradient of this function. Let's call this f of xy. Okay, and I'm going to evaluate that at -1, 2, and I'm going to dot it with u. Okay, well, what's the gradient of my function? Well, the gradient of my function is, well, that's the x derivative is y squared. The y derivative is 2xy. I'm going to evaluate that at -1, 2, right? And I'll dot that with u. Okay, well, what do we get here? Well, if I plug in -1, 2, I get 4, -4. And I'm going to dot that with this guy, 3/5, 4/5. All right, so I take the dot product. What do I get here? I get 4 times 3/5 is 12/5. -4 times 4/5 is -16/5. And so my directional derivative is -4/5. So what we're saying is, if we take that function, xy squared, and we move in the direction of 3, 4, the rate at which the values of this function changes as we move in that direction is -4/5. So we know, for instance, that we're going downhill. So let's just take a look at this. I've plotted this in 3D. So here we have a graph of our function, which was xy squared, right? So that's what we're looking at over here. Right, here's its graph. And we're looking at the directional derivative at the point, what was our point? -1, 2. All right, so x is -1, so we're over here, y is 2. So I've actually plotted the point where we are on the surface down here. Now we're moving in the direction, we said 3, 4. So x is 3, y is 4. We're going this direction. So if I was to point it, we would be going this way, right? And what we deduced by doing the calculation is that we're actually moving, the value of the function is actually decreasing in that direction. So we're kind of going off. Still, you know, maybe isn't so clear by looking at this picture, but that's why we have to do computations, right? So, but when we move off in this direction, we're actually going downhill. The height of the graph is decreasing at a rate of -4/5 z units per every unit we move in that direction.